Hello, geometry students. We are working on day 2 of volume, specifically different types of prisms and then cylinders as well. And today we're actually just going to talk about prisms. I have 2 examples for you. One is a pentagonal prism, just because that one requires a little bit more work to find the area of the base. And then we'll do one composite figure, which is way easier for composite figures for volume. So let's get started just with one example right away. We have a pentagonal prism. Now when you're drawing a 3D pentagonal prism, your pentagon doesn't need to look like a regular pentagon because you're kind of looking at it from a side. You're not looking at it directly down. All of the sides should be perfectly vertical if you're trying to draw it as if you're just looking at it head on. And then you can start connecting your dots there. So your sides that go up and down, or the height of the prism, needs to be vertical, and they should all be the same length, and then you can kind of connect it. If you need to pause there and copy that down, you can. So let's get started. The height is 10, and one of the sides of the base is 12, and that's actually more than enough information to find the volume. So our volume is big B times H, and what does that big B stand for? Yep, it stands for the area of the base. So in this case, the area of the base is a full pentagon, which is going to take a little bit more work than just finding, for example, the area of a triangle. And then the height is already given to us. So I'm just going to plug that right in. So let's plug in what we know so that we really can focus on what we're looking for. So if I'm looking for the area of the base, the area of my base, well, it's a pentagon. Oh, that's not a great pentagon. That's fine. The sides are all 12. I need to know my apothem. That's what I need to find. And so the area of my base is 1/2 apothem times perimeter, perimeter times apothem. And let's figure out what we know and what we're looking for. So it's 1/2 times the apothem times the perimeter. The perimeter is the easiest one to find because it's a regular pentagon, because it's a regular pentagonal prism, meaning it has to be regular. I can find the perimeter much easier. What is 12 times 5? My perimeter there is 60. And then I need to find the apothem. I need to figure out what this distance is. So we're going to kind of blow up that triangle right there. All right, so I know it's 90 degrees. If it wasn't 90 degrees, I wouldn't be able to solve it. That's that 90 degrees right there. It's half of the side length, so that's 6. And I can find this angle measure by taking 360 and actually dividing it by 10, because if I was to divide it by 5, it would be this whole angle, but I only want half of it, so that's 36 degrees. And then I'm going to find the apothem, and the only way to do that is using trig. So I know my opposite, I'm looking for the adjacent, so I'm going to use tangent. Tangent of 36 is equal to opposite over adjacent. In this case, A actually stands for apothem, but it's also the adjacent. And then I solve. Some people had asked me, hey, where did you get that A from? And so I am going to kind of slow down on this part. Normally I'd say, okay, and A is equal to. But some people were asking me to actually show my thinking for this, so I will. In order to get A out of the denominator, I multiplied both sides by A. A is still not by itself. We still are looking for that A value. So I'm going to divide it by tangent of 36, both sides, because tangent of 36 is just a number. It's a decimal. That crosses out, and A is equal to 6 divided by tangent of 36. Plug that in your calculator, and you get technically you could round it to like 2.6, but I'm going to keep it super long, because then I can get a more accurate answer. So I'm going to plug that in. That's my apothem. 8.258. Maybe I'll keep it at that. That is my area. I just need to know exactly what it is. I'll give you a second to type that in your calculator if you're following along with us. Okay, so at this point it would be 247.748, blah, 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 whatever that is. All right, so I have that number, and that is, I finally found the area of the base. So I'm going to plug that in there. So you keep plugging things back in. I got lots of errors going on. 247.748. We'll times that by 10. I don't even need a calculator to do that. I'm just going to move over my decimal 1. And I get 2,477.48 units cubed, because we are talking about volume, so you want to have units cubed. And that would be your final volume. A little bit more work, a little bit more steps than the other ones, only because the area of the base was harder to find than just like, I don't know, if the base was a square. That'd be easier to do. So feel free to pause to write that down. We are going to move on to example 2, our last example, but it's also a composite figure. So we're going to do some drawing, and I'm going to do it slowly. What we are going to do is we're going to take a rectangular prism, and we're going to stick a triangular prism on its side on top of it. So it might be easier maybe just to watch me do it and then to try it on your own. This isn't going to be a cube, even though I'm kind of drawing it like that. That was unintentional. So my base is this rectangular prism. That's super wonky over here. Sorry about that. And then there's this triangular prism that's sitting on top, almost like a house. Oh man, that is not a great picture, but we're going to go with it. Fantastic. Okay, so we're going to mark some of the sides. If you want to do that background, you just do it like normal, just like as if it wasn't there, or like it wasn't a composite figure, that'd be fine. That might be easier to see. Okay, still super wonky. We're going to pretend that those are regular shapes so that they actually look nice. Okay, so we're going to fill in some numbers. This length here is 12. That length, this length or that side length is 8. The height of this shape is 8. And then the last thing you need to know, and I'm going to make a solid line here, even though it probably shouldn't be a solid line, the height of that triangle is 10. Okay, so we have everything we need. The best part about composite figure volumes is you find both volumes, both individual volumes, and add them. And that's it. This is way easier than finding the surface area, I think, and a lot of other people think that, because you can just separate it out, do too many problems, then just add it up at the very end. So I'm going to do two different, oh, it's kind of hard to see, I'm going to do that, there we go. 2 different problems and add it up. Alright, so I'm going to do one problem with this rectangular prism. I prefer to draw it out again. If you're like, I get it, I don't need to do this, then don't, that's fine. I like to draw it out. Okay, so I'm going to redo everything here. If I am looking for the volume of that shape, I need to know the area of the base and the height. I'm going to choose the base to be this, like what's actually sitting on the ground, if you will, because with a rectangular prism, you can just pick whichever base you want. I always try to pick the bottom one. And the area of that base is 8 times 12. Because that would be the rectangle base right there. And 8 times 12 is 96. And then the height, in that case, is 8. Plug that in your calculator. What do you get? 768 units cubed. I don't really need that there because I'm going to do the top one first and then add it up at the end. Okay. We're done with half of it. Now we have a triangular prism. And again, I like to draw it out. You really don't have to if you don't want to. Okay, I've drawn worse. There we go. We're going to stick with it. What is this distance right here? So that distance there is actually 12 because it's a rectangle there. So we know if the bottom is 12, the top's 12. This side over here is going to be 8 because the base is 8. The measurement for the actual base of the rectangular prism is 8. Therefore, that side length is 8. And then the height is 10. Super uber, not drawn a scale. That's all right. Okay, so I'm looking for the volume of a prism, base, and height stays exactly the same. We just need to find what is the base and what is the height. I'm hoping that the height is the easiest one for you to identify, because this is a triangular prism, those rectangles are actually not the side, or the rectangles are the side lengths and not the base. So the area of a base is a triangle, which is 1/2 base times height. And in that case, the base would be 12, the height would be 10. So in that case, the area of the base of the triangular prism, that was a lot, is 60. And then the height is 8, because that's that measurement right there if you were to turn it on its side. And that measurement, I'm almost running out of room, is 480. And at that point, if I'm finding the volume, I'm going to try and use colors here to indicate that you are simply just adding up those two measurements to get your final volume, which is 1,248 units cubed.